Okay, so let's work on this synthesis scheme. All right. And so there's not a whole lot of alternative pathways. So I really do just kind of have to approach this one from the beginning and to kind of move towards the end. So what do we have going on here? So the first thing, it starts with ethyne. So I've got a 2-carbon alkyne, and I'm going to react it with sodium amide and ethyl bromide. Well, that's going to take my 2-carbon alkyne and it's going to add 2 carbons to it. So that's the product of that first reaction. So I got 2 carbons added to it. All right. Okay, so what if I take that 2-carbon and I react it with the dissolving metal reaction? Well, remember that the dissolving metal reaction is poisoned catalyst. So it does a reduction. It reduces the alkyne to an alkene. So I still have 1, 2, 3, 4 4 carbons, but I have an alkene instead of a alkyne. Okay, so what about the next one? It looks like in the next one, I'm adding a bromine in an anti-Markovnikov fashion. So this one is good old HBr in the presence of peroxide. Now what do? I have to take this bromide. It's a 1, 2, 3, 4 carbon bromide. And I'm going to make it into something that has 1, 2, 3, 4, 5, 6 carbons. How do I do that? Well, what was the reagent? Well, that was certainly an alkanide ion, a 2-carbon alkanide ion. Okay, now I'm going to essentially do the same thing again. This time I have to form an alkanide ion from the terminal alkyne and then react that with methyl iodide. And so I get the methyl group added at that terminal end of the alkyne, but everything else just stays the same. So what did I do? Let's recount all of our carbons. So I had 1, 2, 3, 4. I added 1, 2 to get me 6. So that's 1, 2, 3, 4, 5, 6. Then I added 1 other carbon. So that should have a total now of 1, 2, 3, 4, 5, 6, 7 carbons. Okay, and so this one also has 1, 2, 3, 4, 5, 6, 7 carbons. It formed an alkene, and it's in this, instead of being a transalkene, it's a cis alkene. So I still need a poisoned catalyst, but I need a specific poisoned catalyst. And H2 and Lindlar will get you a trans alkene. Okay, so what's going on here? On this one, I've got potassium permanganate, sodium hydroxide in cold conditions. This is the formation of a diol. I do have some clues. So I am going to form a diol, and that's where these 2 oxygens come in. I'm going to have 7 carbons, which I already have. There's 3, 4, 5, 6, 7. So everything else is just hydrogens. Well, why are there 2 with the exact same formula? Well, that's because there's going to be, of course, remember for a diol, this one is a syn addition. And so that means that if I were to draw the alkene and then draw the possible structures, I would have to show them with both possible stereoisomers. And that's what's going on here with my 2 reactants. Now we can certainly rotate so that this is in a typical projection. And if it were in a typical projection, of course, this one would still be down, but this one has moved to the back. It's still syn addition, but because it was syn addition to a cis alkene, we end up with this situation where the OHs actually are facing the same direction once they do the rotation. Okay.